Hi, my name is Tim. I'll be talking about the hardware section of this project. So first off, with the voltage measurement, or the voltmeter, what we are doing is we break this design into three stages. The first stage is a voltage divider, which brings down the input voltage across two terminals from a possibly high 15, plus or minus 15 volts to plus or minus 3 volts. This is then fed into another voltage divider for the range selection. Combined with a mux, what happens is that when the open-ended resistors, as you can see here, are grounded, it applies a voltage divider. For the 1 volt range, no divider is applied, but however for the 5 volt and 12 volt range, the output from stage 1 into stage 3 will be scaled down by a factor of 5 or 12, depending on your selection. Next, stage 3 actually is a differential amplifier, and this is required to find the actual voltage difference between two inputs. That voltage is then amplified by a gain of 7.5 and offset by 2.5 volts to finally output into the ADC a voltage between 1 and 4 volts. Next we have the current measurement, and similar to the voltage measurement, the first stage just ensures that the input voltage isn't too high with the plus or minus 5 volt power supplies. Then the second stage is the instrumentation amplifier. Now what this does is it compares the voltage again across the two terminals, and this time applies a gain of 37.5 up to 750. Practically this works, however there is a little bit of noise, or there is actually a lot of noise because of such high gain in just the input. There's also a 2.5 volt offset, and the ADC input hopefully is around 1 volt to 4 volts. Next we have the resistance measurement and continuity, and simply this is just a voltage divider fed into the ADC, and hopefully for the ranges of 1 kilo ohm to 1 mega ohm, it will read a maximum of 4 volts and a minimum of 0. For continuity, however, if any voltage above 2.5 volts is read, then this means that there is a lack of continuity. So with this project, the next immediate stages are to develop the power supplies and test with the rest of the circuits. We'll need a 5 volt, negative 5 volt, and 2.5 volt regulated rails. Further on, we will require testing and purchasing of a speaker for the continuity and logic indicator. And finally, the PCB design is the most essential step, as we will require it for actual final testing and product demonstration. We'll also need to purchase some components, including surface mount components, to ensure this is possible. I'll now pass on to Jack for a bit more on the firmware.